Hi everyone, this is our deep learning final project. Our topic is facial synthesis pipeline, which can transform a person's face based on different features. These are my teammates with their transformed faces. Also, we have built up a nice looking UI to show the performance and the difference of the result. I will demo it at the end of the presentation. The idea comes from a neural network structure mentioned in deep learning class called Generative Adversarial Network, simply called GAN. It's a class of unsupervised machine learning system consisting of two contesting neural networks, of which one is a generator and the other is discriminator. One common application of GAN is image translation. To be more specific, the face translation, which is what we did in this project. You know, there are too many features on a human's face, like hair colors, the eyes, the nose, the mouth, even the different expressions. What we're about to do is acquiring and classifying those features and translating a random image input to any domains as expected. Here is the issue. Usually, the GAN provides a relationship between only two domains during one-time training, which means we could finish only one type of translation. What if we want, for example, a golden hair smiling girl? It seems like a new model is required. So after some paper review, we found an effective model in which the generators generates multiple domains after one-time training. That's exactly what we need. So here is the start point. By the way, one issue I want to mention here is CUDA setting, because we need both PyTorch and TensorFlow. So an available CUDA is necessary, but we are not familiar with that. So it indeed took a long time for us to solve that problem, but we learned much in return. Here is the training process. In this picture, D represents the discriminator and G represents generator. The generator takes in as inputs both the image and the target domain label and generates a fake image. At the same time, the discriminator takes as inputs both real image and fake image and try to finish a domain classification. One difference here from traditional module is we randomly give the target domain label. Thus, we allow the generator to be flexible to multiple translation. Also, an auxiliary classifier is applied to help the discriminator control multiple domains. Here are the loss functions we used. The first one is adversarial loss, which is used to make the generated images indistinguishable from real images. Another one is domain classification loss. We added the auxiliary classifier on top of D and imposed the domain classification loss when optimizing both D and G. That is, we decompose the objective into two terms, a domain classification loss of real images and a domain classification loss of fake images. However, one issue occurs here after we finish the 200,000 iterations. You can see the picture is very bad. Some features beyond target domain were gradually lost, which resulted in a bad fake image. Even though the targeted features perform well, it seems like we needed to add something like a feedback loop to protect the other features. After some paper reviews, we found an important parameter called reconstruction loss. It tries to reconstruct the original image from the fake image given the original domain label. Thus, guarantee that translated images preserve the content of its input image, while changing only the domain-related part of the inputs. After that, the result looks good. Also, we have struggled in some other issues like the influence of the glasses and also the shape of the hair, and we fixed that through transforming them into new domain labels in parallel with the original labels, like the hair colors, the age, the gender. Also, we have finished some plotting focus functions for the training loss, like what we usually do in our homework, and we attached some of them in our Jupyter book. And last, I'm willing to show you the performance of our UI. We link different options to the domain label in testing process. Thus, we could get access to any domain performance. You can see here, we could change the hair color and gender, also the age. Thus, it helped us to analyze and compare the results more conveniently. That's all for the presentation. Thank you so much.